I'm going to zoom into some of these technologies, or one application area of a technology, which was briefly mentioned already here. But before I do so, let me very briefly say who we are and from which angle we see ourselves as being involved in this subject, the Competence Centre for Nature Conservation, Energy Transformation. We are a federal level institutions. We're trying to progress both nature conservation and energy transformation. Whenever there is a conflict, we want to put the debate on a factual footing and resolve or at least minimize conflicts. And we see focusing on such technical system as one option, how in case of conflict at the approval level, when it comes, for example, for conflicts on how WTGs can be approved or not, how we can really reduce such conflicts. We've been looking into these subjects for quite some time, and today I want to give you a general overview and introduction, while at the same time report the results of our ongoing workshop to you. Our starting points, which we're using for dealing with these technical systems, is of course that we want to make sure that we want to allow extension of WTGs, but we also want to keep protection close to nesting sites in place. At the same time, plant efficiency is an issue because efficiency can be much reduced when we have these general shutdowns, and we want to reduce them to the absolute necessary. In order to do so, it's inevitable to have high performance and reliable system. We must have good control systems for our WTGs, and another important prerequisite for these systems is to systematically and reliably test them on site. And another area we're dealing with at the moment, that's to be clear about what are we doing with the test results, what are the criteria, the yardsticks which we use in order to assess whether or not a certain technical system does fulfill the necessary requirements. As the Competence Centre for Nature Conservation and Energy Transformation, we've been looking into these matters for quite some time. Some of you, the participants, will have seen some of what we're doing in the continuous knowledge transfer. So we've looked at the system. We're doing a regular overview where we publish the systems, the manufacturers that have come up with something which is available in the market. We also list a requirement profile for test purposes, which we are aware is actually being used in order to assess the suitability of a site. We've done an expert meeting on knowledge transfer, which actually has a documentation in German and English, which you can find on our homepage, where I'm sure for all those who can't sort of understand it instantly in every language, that might give you some helpful background. But given all the work we're doing, we've also come up with a joint paper where the Energy on Land Agency was involved as well, where we looked at the status of knowledge as well as put forward unresolved issues which we want to pick up on in this range of workshops we are organizing. So we're looking at the system and the specific clarification of function and efficiency of the technology. But on the other hand, we're also looking to the top right here, where we're looking at areas of application and implementation, because we want to see how the technical systems we assess are actually applied in practice. We started our range of workshops, and we had 4 meetings where we looked at system efficiency, areas of application, questions of approving and implementation. And as a final workshop, we did an expert meeting where we had an extensive discussion on how to assess what was done. And in parallel, another group dealt with an issue which is very important for the operators of the WTGs, namely the revenue losses, what is the reduction of revenue loss if you have on-demand shutdown on the basis of flight activity scenarios rather than a general shutdown. We looked at this and also compared revenue loss on 6 different sites, which we've done on the basis of predictions for our comparative analysis. The results of this work was put together and presented in a very popular online event, which was held just about 3 weeks ago. So it's hot from the presses, as it were. And the inputs we received from the participants at this final meeting are going to find entry into a concluding report, which we will publish before the end of the year. Now, let's give you an overview as to what it is that I would like to share with you. First of all, I'll give you a brief overview about the detection systems. We're talking bird detection exclusively. The detection system that so far we've been applying in Germany. I would like to tell you briefly about how they function and in which relevant areas they are to be used. Then I will talk about, are they useful as avoidance measures, which parameters are important, and finally talk about how they can be used in the approval processes, and end with a conclusion and summary. The detection systems in Germany, we primarily deal with 2 different categories for birds. On the one hand, we have the radar-based detection systems. On the other hand, we have the camera-based detection systems. Radar systems are used not just offshore, also onshore. In this case, we're not looking at just flocks of birds, but also individual birds. Apart from the system we've seen here, there are also combinations of the different systems. In other words, radar plus camera system in combination, where we can weigh the advantages and combine the pros of both systems. Something which isn't listed here is that camera systems could also be applied with some acoustic systems which we are using for aversive conditioning. But radar systems tend to be ground-based. Cameras and camera systems could also be on a met mast, for example, or on the ground. But normally they are in some sort of elevated position on a platform, on a tower. It depends very much what sort of visual angle it is, what the visibility of the surrounding area is, and which restrictions exist there. Some camera systems have wide-angle cameras, and they can detect whether or not a flying object, a bird, is in the detection area, yes or no. Then there are cameras which, in addition to the wide angle, also have a stereo camera system. And having a stereo camera allows you to also measure the range and the distance between the flying object and the rotor blades of wind turbine. That's the sort of information which is very important in order to take the measure of shutdown in time. If a stereo camera is not just stationary, but a moving camera, then we can actually direct it at the flight of the flying object. And if it has a telephoto lens, it can also tell us which birds they are, and we have an automated system for assessment and analysis. So, as I say, a more detailed overview about the different systems and how they're equipped can be found on our website. Regarding the function and the areas for which they're employed, how does it work? As I said, you install a system on the wind turbine or in the proximity, and you do so in such a way that the area to be monitored, in other words, the surrounding parameters, is monitored as well as can be. It can either be a 360-degree radius around a site, or could also be an area above the rotor. It's like having a glass bubble around and above the plant. It could also be that you just want to have a section or a particular angle from which you know that birds primarily fly towards the WTG. Now, if a bird approaches a WTG, in this case from the right direction, then that bird will have to be detected when in a certain distance of the WTG. Detection means you have the information that the system has registered a relevant flying object, has turned up, and is in the detection range, in the detection zone. Once the object has been detected, we classify what it is. Is it one of the targeted species, or is it a bird of a particular size group for which a shutdown is necessary? We are differentiating according to different degrees of accuracy, which are preset. The more accurate and reliable the classification and identification of the flying object is, the better can we ensure that we have a shutdown which is indeed as required, and not a shutdown which refers to a species which is not a relevant factor for collisions. Now let's say the bird continues to move more closely to the wind turbine, then a shutdown signal is instigated. The shutdown will have to be instituted at a certain distance from the wind energy plant to make sure that it can go into coasting down before the bird reaches the rotor blade area, which is the danger zone for the bird. The question is, of course, what's the distance from which a species will have to be recognized without fail so that the safe shutdown can be done in time? Regarding the different systems we have, the question is the detection range sufficient in order to send the signal for a shutdown early enough that the motor will go into coasting down, low speed spin before the bird reaches the turbine blades? The necessary distance for an in-time reaction, i.e. a shutdown, is listed here as the so-called reaction zone. Just how the size of such a reaction zone needs to be will depend on how long it takes the relevant WTG to go from normal operating speed to coasting down. There are different areas. The average will be 30 seconds, just to give you an idea. It is, of course, important to also consider the speed with which the bird continues to fly towards the wind turbine. The higher the speed of flight, the longer the turbine needs to get into coasting down, the larger the reaction zone needs to be as well. In order to identify the reaction zone, you can use averages that will give you an overview as to what sort of distance we generally talk about. But another factor which I find important to mention is that, of course, not every bird which moves from the outer radius and approaches the wind turbine would actually have a collision with a wind turbine. We must understand that, but a collision risk does exist, and we have a precautionary area. And if a collision may happen, we can counteract it by a shutdown. Here again, an overview looking at the wind turbine as the blue dot right in the middle of the two circles. So, seen from here, we have the danger zone, which is in this sort of pink, and then we have yellow, that's the reaction zone, which is necessary to assess for the shutdown. You can see that the reaction zone needs to be set up that the bird needs longer to go through the reaction zone than it takes to put the turbine into coasting down. And of course, this will depend on which species of bird we're talking about. And the detection zone, which is the green outer circle, moves beyond the reaction zone. How far beyond the reaction zone the detection zone needs to be will depend on other considerations, such as do I wish signals to be sent to the plant control system that rotor spin is reduced, so that only if the reaction zone is left will action be taken. Now, we have to see the larger the camera range is, the more time do I have to consider what the reaction of the plant should be. Let me just briefly point out at the information we have about the performance of these systems. And we've seen with all the systems I gave you as an example, we have a very high detection rate, but the distance from which this detection rate is so high varies considerably, from 200 meters to 750 or even 800 meters here for the red kite. This is just to give you an impression. And to make sure I get to my conclusion, I'll skip a few slides. And I hope that after the conference, you will have an opportunity to look at the slides I'm now skipping. What we've done at the moment is we've decided that the system development has clearly shown progress made in recent years, which is encouraging. We also see that the systems, as I've just shown, have very different performance levels, which does not mean that one system is clearly better or more suitable and others would no longer be sort of in the running. We have to look at the different areas of performance in the different application areas where which system is best used. We now have to look after we've had some first successful testing with these systems. We need to make sure that they're actually used in practice, and we think this will have to be done through the German regions, the so-called Länder or federal states. As one of the insights from the workshop is that the detection rate and detection range and range, so detection rate and detection range together are some of the core parameters for the performance of the system. And the technical performance capability of the systems should also be proved by means of certification. Another important thing now that we've started testing some of the systems in reality is we need to clarify when will we say the regulations and requirements have been fulfilled and we can take over the results so that we don't need to keep having to test the systems on every site anew. But we are pretty confident that in the future discussion we will find an answer to that. Thank you very much.